Okay. So what do I do is, you need to count the number of electrons, right? So why don't you, I made an example here in the bottom. Right? This is the first thing that you need to do. Nitrogen is 5, oxygen is 6, minus charges, well, plus charges means one less electron. So there you go, you have a 10 electron to deal with. And you guys can do the same thing on the other one, right? So can you do that? And that's the first practice for you to do. And then once you got that one done, and then I need to, I guess, put nitrogen and oxygen. Okay? I guess just sprinkle what I call sprinkle the electron or atoms there, and I need to start to use my electrons. So first, I guess I need to form the bonding. Okay, so that forming the bonding costs you 2 electrons, right? So you have 8 electrons to deal with, and then you're going to put 1, 2, 3, 4, 5, 6. So you just focus on one by one. This is going to be a horrible example, but we're going to fix that problem by doing much things later. So by doing so, at least oxygen is happy, right? And then how many electrons did I use? This example is actually pretty tricky. So you use 6, you got 2 electrons left, right? So you're just going to use whatever is left over on the other side. And look at this, how horrible it is. Because this one is satisfied octet rule. This one, how many electrons they feel like having it? Only 1, 2, 3, 4, right? You need 4 more electrons to do it, right? So that violates one, but let's also, I guess we all know that this is a negative charge, and I'm pretty sure this will be 2 plus charges if you follow the formulas to have overall charges plus 1. So that's your starting point. And then the rule number 1, when it comes down to carbon, oxygen, nitrogen, the second row, they only can have up to 2p, 8 electron must obey the octet rule. Okay, that's really the one. Okay, anything below 2, like a row 3, row 4, they can have extended, but nitrogen, oxygen, there's no exception to do that. So that's the first fix than anything else. So what do? The easy way to increase the number is, can I share that? Can I share this, right? So can you move the electron? It used to be me, but now I'm going to share it with you. And then what's going to happen to that now is, it used to be nitrogen. Now I'm drawing the triple bond with an oxygen here, nitrogen here. That's what happened, right? I guess now all of a sudden that everything is happy, right? So as far as our oxygen is concerned, this one is just to me, but by sharing it, I'm not losing any octet rule electrons. This is an 8 electrons, that's 8 electrons, so everyone is happy here. Now, we need to finish the formal charge business. This is plus, right? And can you see that? Let's start with the oxygen. Oxygen is 6. They should have 6. 1, 2, 3, 4, 5. 6 minus 5 plus 1. What about this? Nitrogen should 5 electron, right? 5. 1, 2, 3, 4, 5. So nitrogen is 0. This one is plus. Okay. So we can really see that when people write NO plus, what this statement means, NO overall charges plus 1 charges. And by looking at the Lewis structure, we can say that actually this plus charges localize onto oxygen. And that's something that we can do that as well. Let's do the second one. Second example is a little bit more relevant for your post-lab problems. And NO2. So do the same thing. 5, 2 times 6 plus 1 is an 18. So now I'm going to put the nitrogen in the center and oxygen on both sides. Okay. So and then I need to lose. I need to at least 1, 2. So 4 electrons. You use it. 14 electrons. Right. That's the start. And then let's make the oxygen happy at least. 1, 2, 3, 4, 5, 6. So that's 12 electron. We've got 2 electrons left, and that's got to go here. Okay, and then things that we can expedite. This is negative 4 more charges, negative 4 more charges, and we all know that the overall 4 more charges is, the overall charge of this molecule is -1. So therefore, what's the 4 more charges in the middle? Minus, plus 1, right? And you guys can do the same thing. 5 minus 4, that's a plus 1. But I like this, the shortcut way. So this is what I have. Okay, so, and then you look at that. Does it satisfy the octet rule? 1, 2, 3, 4, 5, 6. So, okay, that's the problem, right? They are not happy because this is a 6 electron of disobeying the octet rule. So then what do? You steal the electron, or you're asking the sharing the electron from the oxygen anion to form the double bond. So therefore, unhappy phase is not necessary. So then I'm going to, can you have these 2 electrons donating to me? So therefore, your net structure is nitrogen, what used to be like this, now you have a double bond with an oxygen like this, oxygen. This side stays the same, and then I guess the one in the nitrogen and oxygen has a neutral, so this one is a neutral. So that's the resonance structure on this. Okay, and then somebody will say, well, why this one has to be this way? So let's delete this. Can I write oxygen double bond nitrogen single bond oxygen like this? They go back and forth. Okay, so they go back and forth. So therefore, this is the negative charges there. Overall is -1 charges. So they go back and forth. So this bond is actually, it's like 1, sometimes 2, right? They go back and forth. That's the resonance structure. That's why this double arrow is to show the resonance structures. So the bond order between these two is like a 1.5, right? 1 or 2 in both scenarios. So 3 bonds in total based on these 2 structures. So there you go. You got 3 divided by 2. So it's like a 1.5 bond because you're going back and forth this way. Let's go to the antimony. Antimony, if you look at the periodic table, honestly, actually I don't remember where it is. If you look at that, it's underneath the nitrogen. Okay? If you go down for the nitrogen, so this is the column 5 atoms. And then the chlorine is 7, so, and then minus charges, extra electrons, so +1, 48. You got a lot going on, but it's not that bad because what you do is, this one always go to the kind of surrounding, okay? And then you put the, what I call last class, exotic atom, the one that is kind of singled out. So you put the antimony in the middle, and then you're going to put chlorine, surrounding this, right? And then, okay, so now I need to use 2, 3, 4, 5, 6. 6 bond to use the electrons, so there will be 12 electrons to use, 36 electrons left, and then you need 1, 2, 3, 4, 5, 6. You need to continue to do 2, 3, 4, 5, 6 to satisfy the octet rule, right? This is a halogen is pretty easy atom to deal with because they have 7. They only asking for one bond to satisfy the octet rule and to complete their, and then there's no formal charges. So it's a good scenario. And if this is a case, and that means a 6 times 6, right? 36 electron. So you have nothing left. So no electron extra for the antimony in the middle, and that will be end of it. And then for your final sanity check, what is the formal charges? You see that? Well, what is the charges of the overall molecule? -1. And I know chlorine is all formal charges of 0. So antimony must be -1, right? So that's 1. So that's an easier way to do it. Or if you like the equation, antimony should 5, and you have 6 bonds, so 6. 5 minus 6 is -1, and so that's what. The last one is IO3 minus. This is actually the same practice problem that we discussed last class. So let's do that. Iodine is 7, and oxygen 6. There are 3 of them. So okay, let me do the iodine. So iodine in the middle. If you wanna, and put the oxygen. So I can put. Let me put oxygen in a. Most people will not draw this way. It doesn't matter. Okay, you can put any orientation that you want. So you just let them surrounding this way, and then I want to do 1, 2, 3. So that will be 6, 20 electrons. Okay, there we go. 1, 2, 3, 4, 5, 6. So 18 electrons. 2 electron left. There you go. We got these 2 electrons. And then I would like to put a bracket here. This is a negative charge. Right? And then you, by the time you guys already know, this is always -1, -1, -1. Formal charges. This must be 2 plus, and that's the answer for having these Lewis structures. And like I said, this is too much poor countries and in rich countries. Can we share? Can you share? And to neutralize this, I don't think that I want to share more to make this one to be negative. At least I don't want this one to be 0, and keep this one extra and the last one there. So what I'm saying here is, let me do the different animation this time. So, okay, so these 2 electrons will form this way, right? These 2 electrons, okay, how do I undo? Let me choose a different one then. Okay, these 2 electrons are gone, and then you're gonna form extra bond here, okay? Can you see that? And then by doing so, what's gonna happen is, this is gone, that's gone, and by sharing 2 more electrons, your formal charges of this one is gone too. Right? So only 1 O minus is there among 3, and they can choose to be wherever they want. So therefore, actually, this one is 1/3 minus, 1/3 minus, 1/3 minus, and they're kind of bouncing back. And those are the 3 resonance structures to do that. Okay, what's the formal charges? Just so for make sure, this must be 0. Let's do it one more time. 7 should 1, 2, 3, 4, 5, 6, 7. Right? 7 minus 7 is 0. So it makes sense. This you will learn more like I don't know. You guys remember when you were in high school? Did you guys talk about Vesper theory, shapes of molecule? This one is not, doesn't look that way. It's just easier for me to write. This one now should have tetrahedral. We're gonna go through that probably next exam topics. We are not there yet. We just want to make sure that does it satisfy the octet rule, what is the 4 mole charges? Can I minimize it? By minimizing it, we are allowed to disobey the octet rule if the atom is big enough. Right? It's not the second law, and then we can use the octet rule, extended octet rule.